Okay, guys, last section for the unit. Take a deep breath. We're going to need some patience on this one, okay? This goes back and it takes a lot of the information from chapter 1 and some of the previous sections to see what these functions look like. So going from last class, if you decided to use Desmos, you'd realize the top two equations here gave us increasing functions, and the bottom two equations gave us decreasing functions. So we're going to try and curve sketch today, or at least graph without creating a table of values. So what you should notice from the first two is that our b value is greater than 1, and from the second one, our b values are between 0 and 1. Now, the other thing that you should notice, and I'm not graphing them for you, I'm going to do the bottom ones. What you should notice is that the larger the b value, the greater the increase. So 5 to the x is going to increase a lot faster than 2 to the x. Okay. Versus, right, so 5 to the x would look like this, whereas 2 to the x might look like that. Okay. Whereas half an x to the 0.25x, this one would decrease much quicker compared, versus something that decreased maybe like that, so 0.5x. So the farther away the number is from 1, the greater the increase or decrease that you would have. Okay? All right, I've got 8 graphs below. We're going to graph them all. If you need to pause the video right now and graph them by hand instead of using Desmos, I'm fine with that. I'm going to load up Desmos, but if you need to pause your video, you can. All right, so let's look at y equals 3 to the 2x and y equals 2 to the 2x. What I want you to notice when you graph them is that 3 to the x, if you count up, 1, 2, 3, crosses at 3. Y to the 6x crosses at 6. So the value in front is your y-intercept. Okay. Now we've got, it's hard to see here, but this is 2 to the positive x, and this is 2 to the negative x. So let's look at what happens there. Okay, this looks like the blue line. Sorry. This one looks like the blue line, except that it's decreasing instead of increasing. If you go back to your first unit, it's actually being reflected in your y-axis. It's like there's a mirror right here, okay? So this negative up in the exponent is a reflection in the y-axis. Okay? Let's take a look at the next two. We have 2x plus 1, and then we have 2x minus 1. It looks like this one has been lifted up 1 unit and this one has been brought down 1 unit, right? Because remember, you should have your asymptote at 0, but here my asymptote is at 1 and here my asymptote is at -1, okay? So this, by adding or subtracting a number to your base function, is going to shift it upwards or shift it downwards. Hopefully all of this starts to sound really familiar. And then up here, up in the exponent, if we decided to change this +1 and we put it up in the exponent, oops, there we go. Oh, it did it again. There we go, much better. Again, it might be really hard. Let's look at the blue one first. So when I add 1 in the exponent, if you take a quick look, it looks like my graph has gone up a bit, but it isn't. What's really happened is that my graph has been shifted left 1 unit. And this one here, my graph is going to be shifted right 1 unit. So by shifting it left, you can imagine that my y-axis should have been here. Okay, versus on this one over here. Okay, so this has been shifted to the left, this one's been shifted to the right. Okay, so now let's get on to what you're actually supposed to do. let's go back, refresh our memories with everything from Unit 1. We looked at curve sketching functions of this form. A was a vertical stretch or compression. Your C value, remember vertical is up and down, right? The C value shifted upwards or shifted downwards. If it was positive, it shifted up. If it was negative, it shifted down. The D value went left and right. If it was X plus a number, it went to the left because of the subtraction sign in the equation. If it said X if it said X plus a number, then it shifted left. If it said X minus a number, it shifted right. And then your K value was the one that was new to you this year. This is the horizontal stretch and compressions and reflections, okay? So if it was a fraction, it was a horizontal stretch. If it was a whole number, it was a horizontal compression. And if it was negative, it was a reflection in the y-axis. So we can take these ideas and we can apply them to an exponential equation. So this B is your base. The A value is the same A that you would have up here. If it's out in front and it's positive, that will be your new y-intercept. That means that your graph is being vertically stretched or compressed. If it is negative, it is reflected. Okay, the same thing with the D, the K, and the C. They are all identical. Now, we looked a little bit at the mapping rule. If you were comfortable with the mapping rule in chapter 1, you should be okay here. I'm going to do some examples, and then hopefully it will help you remember all of this. So let's take a look at 3 different equations. You do not need to curve sketch them or graph them. You can use the mapping rule, or for you, you can use Desmos. I'm okay with that. So here are your 3 equations. If I look at this one, my base is in here. It is the number by itself, which means this is my D value, this is the C value, and this is the A value. Okay. So this 4, the 4 means that we are going to be vertically stretched by 4. The 5, notice that it's a plus 5. It is going to be horizontally shifted or translated left 5 units. And the -1, now remember the 5, because it's in the brackets, technically it is a -5, even though it says plus 5. And then the -1 means that this is going to be a shift down 1 unit. Okay, so those are all the transformations that would happen to this. If you used the A, the D, and the C, you could plug them into your mapping function, and you could come up with your new equation. Please go back to Unit 1 if you need to review that. Okay. This one over here, again, this -2, it is outside, so that -2 would be a vertical stretch by 2. The 3 is the base, I'm not going to touch it, and the -1, because it's inside that brackets, X -1, really this is a +1, so this will be a horizontal shift or translation 1 unit right. Okay, and then this one here, we've got again a few things going on. There's the 4 with the exponents, there's no number in front, so there is no A value. And this is kind of the more challenging part. Whenever you see something in the exponent, you do need to factor it. So before you can actually start looking at all the values, anytime that something is in an exponent, you should factor it. So I'm going to common factor a -2. I would be left with X plus 2. This way you can clearly see a K value, and you can clearly see the D value. Okay, and then the plus 3 at the back, this is my C value. Okay, so looking at the -2, that's my K value. That means that this is a horizontal compression. Okay, the fact that it's a 2 means it's a horizontal compression of a half. The fact that it's negative means that it's going to be reflected horizontally, so it's a reflection in the y-axis, okay, because it's a left and right reflection. The D value would be the +2. That one means that this is going to be, now it's, well, it's a -2, but it says +2. So inside your brackets, you know it's going to be a -2. So this is going to be a horizontal shift left 2 units. And then the last one that you have is the 3 that is being added at the back. That is going to be a vertical shift up 3 units. Okay, we're going to stop there. That's all I really want for you to do for this year. Ideally, I would love it if you could curve sketch them, but I haven't found a good way to be able to express it to you and teach it to you online. If you wanted to try and find your own videos, you can, but I'm not going to ask you any questions. You will need to know something like that for next year. So for this year, just do your best, identify the A, the K, the D, and the C, and be able to tell me what translations are happening. The last slide is just a summary of what you've done and how it would help for your translations, okay? Or for your exponential functions. Guys, good luck. You've got your task posted, and it's due next Friday, I believe. Have a great night. Take care.